An important aspect of event-driven architecture is understanding how your entire system is performing. Everything can be running smoothly, and services are consuming and publishing events. Then seemingly, out of nowhere, one service has an issue, and then it has a cascading effect on your entire system. I'm going to explain why some of this occurs and why it's really important to have metrics, dashboards, and alarms so that you can be proactive and keep your entire system running smoothly. Hey everybody, it's Derek Comartin from CodeOpinion.com. If you're new to my channel, I post videos on software architecture and design and topics like this. So if you're in these type of topics, make sure to subscribe. This video is brought to you by EventStoreDB, the stream database built from the ground up for event sourcing, CQRS, and event-driven microservices. For more on EventStoreDB, check out the link in the description. So I have the end service bus monitoring demo running, and it's really cool. It has different endpoints that are illustrated here. I'm gonna wanna dig specifically into the sales endpoint to illustrate this. Now this demo is really cool because what it can do is I can fiddle with some processing time numbers and how many messages are queued per second to really show this. So what I have set up right now is I have a queue length of 2 messages that are sitting in our queue, 1 roughly around there. We're seeing what our throughput is, and I'm processing basically about 8 messages a second. And our processing time is about around 315, 20, somewhere around there, milliseconds for each individual message. And that processing time is once we actually start consuming a message, how long it actually takes us. Critical time is really important because what that is from the moment a message is queued to when we actually consume it and finish processing it, that's what our critical time is. So we can see really that everything is running fine. We really only have maybe 1 or 2 messages in our queue at any given time. We're processing everything fine. But what I can do here is I can actually start making our processing time. Let's say there's some type of bug, and I'll explain some of these reasons why. Let's say all of a sudden, well, our processing time shoots up to about 800 milliseconds. Now what we can start seeing is that our throughput went down, and now our queue's starting to fill up. Now, why could this happen? Why would our processing time increase? Why are there other things that would decrease our throughput? There's a lot of reasons why this can happen. This is why these types of dashboards, metrics in terms of queue length, throughput, processing time, and critical time are really, really important. So let's get into why this can happen. If you're using a typical queue-based broker, you're thinking of queue length, and that's what was filling up in our example as our processing time went up and our throughput went down. Same applies if you're using something like Kafka and a distributed log. You may refer to this more as consumer lag. At the end of the day, the problem is that we're producing messages faster than we can consume and process them. This means when your throughput's high enough, you're never really gonna get backed up. So when we're publishing messages, our consumers are picking those up and processing them, our throughput's high enough based on how long it's taking our consumers to process these messages, how many consumers that we have, so that our throughput will be high enough where we're not going to back up our queue or our topic like I was illustrating. There may be points where we do have messages in our queue, and I had kind of roughly about 2 per second, because maybe we have an influx at any given time where more messages come in than what we can process at that time, but it's kind of a window of time. We're going to kind of have peaks and valleys, but overall, we have a high enough throughput where we're not gonna just continuously back up our queue and not be able to catch up. Now, where things go bad is when we just can't keep up and our processing time's up, or we just have more messages coming in. So we're producing these messages, but we just can't consume them fast enough. And this is exactly what I was illustrating in the dashboard, and we're just basically filling up that queue or our topic, and we just really can never catch back up. So what are the things that are gonna kill our throughput and wreak havoc on our system? Well, it's an increased input rate, meaning that, again, we're producing messages quicker. The processing time, if we have intermittent issues with the processing of messages, this can, again, wreak havoc and kill our throughput. And lastly, poison messages. This is why monitoring, metrics, dashboards, alarms are really critical in an event-driven architecture. You want to proactively know when something's going offside so you can address it immediately. What are the things that you can do to increase throughput when things are really going sideways? Now, assuming our processing time has stayed the same, and really it is just more messages coming in that we need to consume, that we need to process, it is just adding more consumers using the competing consumers pattern. So this means that we have a producer, we're producing messages, we have our consumer, let's say it's just a single instance of that consumer, but as our messages are coming in quicker, we can just add another instance of a consumer so it can process more messages concurrently. The issue here is any downstream services or infrastructure that you might have. As you can see, if I had a single consumer, I was processing messages, let's just say sequentially, one at a time, our database was able to handle that. If all of a sudden we started adding more consumers and starting processing messages concurrently, and they're also interacting with that database, well, that could now basically push all that extra load to our database. So yeah, we can process more messages concurrently, but we may affect downstream services because we're doing more work. Another thing to look at is really just what are you doing when you're processing a message? There's often intermittent issues that can occur that can really increase processing time because your dependency on something else. And again, when processing time goes up for a consumer, throughput's gonna go down. So that means that when we're processing a message, let's say that our consumer, we have to reach out via HTTP to some external service. And on the normal, it's really responsive, it's low latency, no big deal. But let's say all of a sudden there's an issue with that external service and we have a lot of messages that we consume that need to reach out to that external service. If it used to take 50 milliseconds to make that call and now all of a sudden it takes 2 seconds to make that call, our throughput's gonna go down, our processing time's gonna go up. So realize when you're writing consumers, what they're doing and what the effects can have on processing time. If what you're depending on, it has issues, it's gonna be high latency, it matters. I also mentioned poison messages, which are messages that you cannot consume and you fail to process. So the example here is if you're using something like Kafka, this really matters because if you're using partitions specifically for ordering and you want to process messages in order. So the idea here is if we have something like Kafka, let's say we have two partitions, P1 and P2, and the way it works is that you can have a single consumer within a consumer group associated to consume messages from an individual partition. So I have partition 1 is going to be consumed by one consumer, P1 at the top here, and P2, that second partition, is going to be consuming messages for P2, that consumer. So as we go here, this is how it works, is that each message can be done concurrently. However, they're going to be done by their own respective consumers that are associated to them. Where this goes wrong is that if we have a poison message and we're expecting messages to be consumed in order. So we have a message that's sent to P1. We have other messages being appended, added to that topic, but that message, poison message, we cannot consume it. We're failing to consume and process that message. What do we do at this point? Because we just keep adding messages to that partition, to that topic. But we can't continue on, or can we? Our options are really, we could discard that message, maybe place it in dead letter queue, look at it manually and process it again, or we just sit there, wait and block because we can't move on. This actually was the example used in Wix.com, and what they were doing was just because they're using Kafka, you can't discard the message. What you have to do is move your offset over it so you can continue processing. But this has a lot of implications if you're expecting to process messages in order, and that's why you're using something like Kafka, is that you have a single consumer within a group that's processing messages from a partition in order. If you have that expectation, you're gonna have issues if you, for example, have a poison message. At the very end of this video, I'll be linking to another video that I've covered specifically from Wix.com and a blog post that they had, and some of the kind of the troubles related to exactly like this with Kafka. A really important aspect of event-driven architecture is dashboards like this, is the metrics, is alarming on these metrics so you understand really how your system is running. Now, there is no real silver bullet in terms of how you increase throughput. You have different options. If you want to use the competing consumers pattern and add more consumers, that's fine. You can process more messages concurrently and increase throughput. However, realize the effects that you may have on downstream services or infrastructure. If you're using something like Kafka and partitions and you have a poison message, well, you need to deal with that on what you want to do if you're processing messages in order for a reason. Again, you want to get ahead. You want to know immediately when this is happening. Same idea goes with just inflow of messages. Maybe you need to look at how you're publishing messages, at the rate of which you're doing them, and individually about how long the processing time is taking it. It could be something transient, like I mentioned, if you're reaching out to an external service where, yeah, sure, on the happy path, everything's fine, but all of a sudden it has some type of issue and that can cause a lot of strain on your own system. So being aware of what you're doing with consumers. The key is having dashboards, having metrics and alarms on those metrics so that you can get ahead of it. that you know, uh-oh, things might be going sideways here, we need to address it. If you enjoyed this video, please give it a thumbs up. If you want to chat with other software developers about software architecture and design and topics like this, you can join my channel and get access to a private Discord server. Links in the description on how to join. If you have any other thoughts or questions, make sure to leave a comment, and please subscribe for more videos on software architecture and design. Thanks.